Okay, so this is the video for my lesson. Today we're going to be talking about radical equations. So in the past we've talked about rewriting expressions, and those expressions were typically rational, which means they didn't have radicals. They were just usually of degree 2. So now we're moving into the idea of radical equations, and I'm just showing my work instead of seeing me because this is the best way to actually be able to see my work compared to far away blurry board. So this is the best I can do, and I'll show you how I'm doing my work on the sheet of paper on the overhead. So what we're trying to do today, it's the same as basically yesterday, but instead of rational, we're doing radical. So I want you guys to recognize an equation for being radical. So you'll see the square root, or eventually we'll end up using cube roots, but right now we're just sticking to square roots. So recognize that they're square roots. I want you guys to be able to solve for single variable, and that single variable will be x. And then again, understand extraneous solutions and figure out which one is the real solution and which one is the extraneous solution. And just be comfortable solving these with a lot of accuracy. So these are pretty simple, and you're going to see a lot of different types. And based on how we've rewritten things, how we've used exponents, and how we solve the rational equations, we should be able to apply those to how we solve radical equations. So we're going to start with this introductory problem, and that is x minus 6 equals square root of x. So x minus 6 equals the square root of x. So first I want you guys to work on your own, and after that just start thinking on your own, and then after that I want you guys to talk to the person next to you and try and figure something out. Hopefully you guys can cooperatively learn and figure out a little bit more ideas, and then maybe working together will help you guys figure out how to solve it. This should be challenging. We haven't really seen how to solve for a square root. These are new. Radical equations are new. So try and take your ideas of what we've done in the past and apply it to this. If you guys need any hints, I'll be walking around. Just try and think about canceling out that square root, or getting everything on one side, making sure it's equal to 0. So it's the same things that we've done before, but it's a little more complex with the radicals. So obviously there's not a class to actually go through this, but ideally you guys would be cooperatively learning. So working out on yourself, and then working with a partner, and then eventually sharing what your answers are. There's no one here to share, so I'll just be going through how to go through solving this. So for starters, x minus 6 equals square root of x. Like I said, what you want to do is cancel out the square root. So, but to do this, we want to square both sides. We do this because squaring a square root cancels it out. So square root of x squared cancels out the square root, and you end up with x. And then x minus 6 squared, that's the same as x minus 6 times x minus 6. So, and then again, square root of x squared is the same as x. Because you can picture that as square root of x times square root of x, and that is the same thing as x. So if you think about the squares, again, how we've done it in the past, it's the same thing as cancel it out by squaring both sides. And this works because whatever you do to one side, you have to do to the other. And if you do it to both sides, it cancels out, and you're able to do that to the equation. So now this is in a form that we are pretty familiar with. So x minus 6 and x minus 6, those two times each other. We're going to do our normal way of factoring it. So x times x squared, x times negative 6 is negative 6x, and then now front to here, so negative 6 times x is negative 6x. Negative 6 times 6 is, right, positive 36, because negative times a negative is a positive. And then, again, equal to x, so bring that down. And now we have to simplify and eventually solve for x. So what do we do here to simplify it? Right, we can start with adding the like terms. So negative 6x and negative 6x, you can put those together and get negative 12x, and then everything else stays the same. And then Again, in order to get this into a form that we're comfortable solving, we have to, good, multiply x on both sides, or not multiply, subtract x on both sides. So we want to get all the x's onto one side in order to solve it. Because we're most comfortable solving when the equation is equal to 0. So now that we've done this, we still have x squared, but now negative 12x minus x, we think of this as just 1x. So 12 minus 1 is negative 13. And since it's x, it's negative 13x. Then I have the positive 36 stays the same. And then since we've canceled out the x on that side, it equals 0. You guys should recognize this from yesterday's lesson. What was the exit ticket? It was this exact equation. So we solve this the regular way. How are we going to do this? Factor it out. So think of what factor of 36 add together to equal negative 13. So which ones come to mind? All right, exactly. So x minus 9, that's one of them, and the x minus 4 equals 0. And this does the same thing because we see that negative 9x and negative 4x equals negative 13x. And then also, if you guys just want to check in your head, or if you have a piece of scratch paper, you can do that too, just to confirm that x times x is x squared, x times negative 4 minus x times negative 9. So negative 9x minus 4x is negative 13x, so that's good. And then negative 9 times negative 4 is 36 because the negative cancel out. And another way to differentiate how you do this, it doesn't have to be x minus 9 times x minus 4. You could also write it as x minus 4 and x minus 9 equals 0 because order doesn't matter in multiplication. So you can think of this as multiplication between these two. So order doesn't matter in that particular case. Now that we have it here, we just do our regular solving for x. So you can think of this as x minus 9 equals 0 and x minus 4 equals 0. And because we have this is just basic algebra. Add 9 to both sides, x equals 9. And we can add 4 to both sides, x equals 4. Now, are we done? Do we have our two answers? We do have two answers, but what's the most important part? We've talked about this before. Right, checking for extraneous solutions. So what we're going to do is put in both these x's to the original equation. And as you remember, the original equation is x minus 6 equals square root of x. It's important that you make sure you know what the exact original equation was, because I kind of modified it here. So that's not the original equation. You have to plug it into the original equation. Because obviously if you plug it into, say, simplified a part of the equation, it's going to look a little different. It's going to look off. It's going to actually solve. So for checking extraneous solutions, remember, you have to plug it into the original equation. So starting with 9. So we put 9 in for x. So 9 minus 6 equals square root of 9. What's 9 minus 6? 3. What's the square root of 9? 3. So that works out. So 9 is definitely one of our solutions. And now if we do the other side, if we put 4 in for x, so 4 minus 6 equals square root of 4. 4 minus 6 is, right, negative 2. And then square root of 4 is 2. Those equal each other? No, they don't. So since those don't equal each other, x equals 4 is extraneous. So it doesn't actually count as the equation, or as the answer. So the one true answer for x is x equals 9. And again, we went through how to solve for this exact x squared minus 13x plus 36 equals 0 because this was in our IP ticket. So again, we're going to keep going through the same process for solving for a single variable. It's just that how you rewrite it and simplify it, that's going to vary. It varies how you rewrite it or simplify it. So that's important that you know different ways to rewrite and simplify. So now that you guys have that down and you guys have worked together, I'm going to go into the true part of the lesson. So now before it was x minus 6 equals square root of x. So that was just one single variable inside the square root of x. What do you think we do if it's, say, 5x minus 4 equals x minus 2? So this is the new type of equation that we might be seeing. So 5x minus 4, so square root of 5x minus 4 equals x minus 2. Take a second and just think about how we would solve this. Again, this is the lecture part, so you're not working on your own, just take a second to think. All right, so we do this in the same exact way, except instead of it being a single variable inside the square root, it's an expression. So again, we do the same thing with squaring both sides, because we want to get rid of the square root in radical expressions. Remember that. You want to get rid of the square root in radical expressions, and you do that by multiplying, or not multiplying, by squaring both sides. So now, canceling out, square root of 5x minus 4, that's the same thing as just regular 5x minus 4. Because it works the same way. It's just square root of 5x minus 4 times square root of 5x minus 4, which equals just the expression on the inside. So it might seem a little confusing at first because, oh, it's a full expression inside the square root instead of just a single variable. But you do the same, it works the same exact way. And then x minus 2 squared is the same as x minus 2 times x minus 2. So again, this we're fairly familiar with. Obviously, it's a little more complex because we have a 5x instead of a single variable, but we're able to make do. So now, x minus 2 times x minus 2. First, we'll bring the 5x minus 4 down. So then, if we're gonna factor this out, it's x times x, which is x squared, x times negative 2, which is negative 2x, 2x, or negative 2 times x, which is negative 2x, and then negative 2 times negative 2, which is positive 4. And now we gotta simplify it. We gotta get it in a form that we can end up factoring out and solving for x. So again, we can bring down the 5x minus 4, and then we can end up doing these like terms. These like terms can be added together, or I guess subtracted, however you want to say it, but negative 2x minus 2x is the same as negative 4x plus 4, bring that down 2. And now, what do we do here? It's not that we have one single variable or one single term on the one side. How are we going to do this? Exactly, we do the same thing by canceling out both sides. So you add 4 to both sides, and you minus 5x to both sides. It's the same exact way of doing it. So this way these cancel out, and then you get them all onto one side. So 0, because these cancel out, equals x squared, negative 4x minus 5x, negative 9x, and then 4 plus 4 is 8. So now that's in a way that we're comfortable with. And then if you feel more comfortable with everything on the left side and the 0 on the right, you can just rewrite it because the equal sign order doesn't matter. So we'll put it in that form just because that's what you guys are comfortable saying. And when you guys are doing your homework, or eventually when we do the test, that's how you guys can rewrite it. You'll have plenty of room to do your work. And now it should be in a form that we're able to solve for. So can anyone think of ways we can solve this? Which two x minus, or x plus or minus a number times each other we can get? So, different factors of 8. We have 8 and 1, or we have 4 and 2. Can 4 and 2 end up as negative 9? No, they can't. So what about 8 and 1? That's true. 8 plus 1 equals 9, but it has to be a negative 9. So what do we have to do? Good. X minus 8 times x minus 1 equals 0. Because remember, you can use two negatives for a positive. So negative 8 times negative 1 is positive 8. So if it's a positive there, you want it to be a either two positives or two negatives. And if it's a negative, it needs to be one negative and one positive. So make sure you remember that. And again, you can swap the order of these. That's a way that you can differentiate it. It doesn't matter because order doesn't matter in this multiplication. And I'll grade both the same way. So however you're more comfortable seeing it, that's how you can do it. And now from here, how do we do this? Good. X minus 8 equals 0, and x minus 1 equals 0. So now that we've done this, pretty simple. Add 8 on both sides to get x equals 8. Add 1 on both sides to get x equals 1. Are we done? No, we're not done. Got to plug in and make sure we don't have extraneous solutions. Remember, our original equation is 5x minus 4. The square root of 5x minus 4 equals x minus 2. Remember, that's our original equation. You need to make sure that you plug it into the original equation so there's no room for error. I'm going to be checking on your homework and on the tests that you plug it into the original equation, because there's different problems that may arise if you plug it into a simplification of it. So let's start with 8. If we plug 8 into x, square root of 8 minus 4 equals 8 minus 2. So how do we solve this? Think about earlier math, even in elementary school. Order of operations. So first things we do is we can picture inside the square root as the same thing as inside of parentheses. So it's 5 times 8. What's 5 times 8? 40, right? Minus 4 equals 8 minus 2. 40 minus 4, 36. 8 minus 2 equals 6. What's the square root of 36? Right, 6. So 6 equals 6. Is that right? It is. So 8 is a true solution. It's not extraneous. Now let's plug in 1 into the equation. So we have 5 times 1 minus 4 equals 1 minus 2. So again, same order. 5 times 1 is 5 minus 4. And then 1 minus 2 is negative 1. And then inside the square root, we get 5 minus 4 is 1 equals negative 1. And the square root of 1 is, that's right, 1. Does 1 equal negative 1? No, they're actually opposites, so they don't equal each other. So that means that this is extraneous. It's not one of the true solutions. So again, extraneous means that it's not a solution. You need to make sure you check for extraneous solutions so you're able to ensure that you have that one true solution, because x has to be able to be put into the original equation when you're solving it. That's the point of solving for x, so you can plug it into the original equation. This is very important problem solving that you have to be doing. So now we're going to be, after you guys have this all written down, I'll give you guys a minute or two. All right, that should be good. So after we have this all written down, we're going to go through our exit ticket. So take out another sheet of paper. And the exit ticket problem is -1 equals square root x plus 11 minus x. So this is a tough one. I want you guys to really think, and I'll walk around the room, and this is an individual activity. I want you guys to work alone. Talk to me if you really do feel the need to work with a partner, but I want you guys to try this out on your own. So let's try this out on our own. So I see some of you guys are finishing up. Once you guys are finished up, turn them into the front of the room. I want you guys to turn them in before I go over this because I want to see what you guys know based on the lesson. So get finished up and turn them up here. How did it go? Did it go good? Good. Did it go good? Oh, it didn't? I'll go over it and we'll see what you did wrong. I really want to make sure all you guys make sure you get this in. I need to see how you guys did based on how I taught, because it's one thing going over it with you, it's another thing working on it on your own. So not only do you guys work at the beginning with a partner, but you guys also have to be able to work on your own. That's independent instruction. You guys want to be able to do it on your own because when you take the final test, you'll have to work on your own. So make sure you know exactly how to work on your own for all this. All right, looks like that's the last one. Turn it in. So now that you guys are starting to apply what you learned today, let's go over it. Let's talk about how you solve this. So this is in a unique form. Square root is not on its own side. So what is it that some of you guys decide to do? Let me ask some questions. What did you guys decide to do? Square both sides. All right, let's see what happens when we square both sides like you said. So you can square this and square this. So what do we get here? Yes, we can eventually cancel out the square root, but this isn't the same as just squaring this and squaring this. What does that expression actually look like? If we square both sides immediately right from here, what's it going to look like? It's going to look like this. So this expression ends up looking like times. So we don't want to immediately square both sides because then we end up with a super complex expression like this. And then we're just putting extra work for us. Yes, if you work through this whole thing, you will eventually end up with the answer, but there's a much easier way to go through this. Anybody know? Anybody want to share? All right, so let's go back to our regular equation from the start. So we don't want to do it this way. There's a much easier way. And yeah, if you guys ended up with the right answer and you did this work, I'm going to mark it right because if you have all the work and you did in fact get rid of the square root, it's the right way, but I'm going to show you guys an easier way to do it. What you have to do is get the square root by itself. So what's the easy way to do this? This is the lone x that's not in the square root. So we're going to want to cancel it, get it on the other side. So add x. So this gets out, and then this side is x minus 1 equals square root of x plus 11. And now, this is exactly like the problem I showed you guys in the lecture. Now you guys can square both sides as normal. And then x minus 1 squared is the same as x minus 1 times x minus 1. And x plus square root of x plus 11 squared is good. X plus 11. So you see, based on how I've taught you guys are able to apply this, but there's going to be variety in how you guys go through solving these. So you guys have to take what you've already learned, take what's in your toolbox, really think critically on how to solve, and then you should be able to solve more and more things, more and more complex, just by using the base things. So we know how to get things on other sides by doing the same operation on both sides of the equal sign. And we know how to cancel off the square root. You guys should know how to do this. Obviously, it's a lot different, and it may take some explaining, but after this, you should be able to do any problem thrown at you in the homework and eventually on the test. So now again, we're able to do the regular x times x squared. X times negative 1 is negative x. Now over here, negative 1 times x is negative x. Negative 1 times negative 1 is positive 1 equals, bring this down. And now the two like terms, so it's x squared minus 2x plus 1 equals x plus 11. And now, just like the problem we just did in the lecture, get everything on one side and make sure it's equal to 0. So subtract both of these on both sides. And then we end up with x squared minus 3x minus 10 equals 0. And now think about ways factors of 10, or not just factors of 10. What did I say before? Factors of negative 10. So one has to be positive and one has to be negative. So it's either negative 10 and 1, negative 1 and 10, 5 and 2, negative 5 and 2, or negative 2 and 5. So which ones do we think of? When I first think of it, I think it has to be negative 3. So we're going to do x equals negative 5 times x plus 2. So if you think about it, negative 5x plus 2 is the same, or negative 5x plus 2x, negative 5x plus 2x equals negative 3x. And if you want to go through it to the side or on a scratch sheet of paper, that's fine. So you can end up seeing that this equals the same thing as what we have over here. So now, solve for the single variable x as normal. So x minus 5 equals 0, x plus 2 equals 0. And now, add 5 to both sides, x equals 5, minus 2 on both sides, x equals negative 2. Now, I keep preaching it. Are we done yet? No. Extraneous solutions. Let's find them. So we're going to use the original equation, which is negative 1 equals square root of x plus 11 minus x. So let's start with plugging in 5. So we plug in 5 here. We get negative 1 equals square root 5 plus 11 minus 5. So negative 1 equals, what's 5 times 11? Right, 16 minus 5. If we keep simplifying, what's the square root of 16? 4, good. Oh, not bad. Pardon me, so square root of 16 is 4 minus 5. Then what's 4 minus 5? 4 minus 5 is negative 1. So again, this equals one another. So 5 is a true solution. X does equal 5. Now, you guys are probably think like, oh, then negative 2 probably is the extraneous solution. I still want to see the work of you checking for it because I will grade you guys based on the work you have for it. So quickly running out of time, negative 1 equals, put in negative 2 plus 11 minus 2. Negative 1 equals negative 2 plus 11 minus negative 2. So you got to make sure that you keep the minus. So negative 1 equals negative 2 plus 11 is 9. Minus negative 2 is the same as plus 2. Square root of 9 is 3, right? Plus 2. End up with 1 equals 5. Those aren't equal to each other? No. So that makes negative 2, pardon me, extraneous solution. So, even if you already find your normal solution and you're assuming that this is the extraneous solution, I still want to see the work. So, what we did today is we started by working together on the introductory problem, so you guys were able to cooperatively learn, and then with the exit ticket, you guys were independently learning, kind of working out yourselves. So those are two different ways that you guys have kind of gotten comfortable with doing this. So again, now your arsenal, or your toolbox, is full of tools for solving problems, and you will definitely be ready for the upcoming problems on homework and tests. So remember, we started with how to rewrite equations based on the exponents. We went into how to use exponents, like what do exponents mean? So like square is the same as that times that, or cubed is the same as that times that times that. And then yesterday we went into rational expressions, so just regular degree 2 polynomials and solving for x. And now we're able to solve if there's a radical. So every single time we're in class, we're learning how to put different tools in our toolbox and solve more and more math. And this is even important in life because you're going to constantly be learning different strategies for how to solve different problems. Because even if you don't end up going into a math field, you will need to know how to problem solve. So that's it. Thanks, folks.